Now on to part B. We are asked to calculate the common speed v of the two balls after the collision. I have drawn the pictures here to help us along. Before we have x moving to the right with 3 meters per second, and y we have moving upwards at 9.6 at an angle of 60. So we have a component 9.6 cos 60 in the x direction, and perpendicular to that we have 9.6 sin 60. This is before, okay, collision. After collision, the two objects coalesce, they stick together, and they move in the vertical direction with velocity v. Okay, now we are asked to calculate the common speed v of the two balls after the collision. We are asked to find what is v. So in part A, we used the principle of the conservation of momentum in the x direction. Now all we'll do is we'll use the same idea in the y direction. That's what I've written here, okay? Using the same principle in the y direction. So momentum, sum of momentum before collision will be sum of momentum after collision. Remember, we're dealing with the y direction. So before a collision, we'll have, let me write it here, before collision, let's take ball x first. The mass is 4, and in the y direction there is no speed, so 4 times 0 plus, for the ball y we have 2.5 times, what is the component in the vertical direction? Good, 9.6 sin 60. This is the sum of momentum before collision. That's what you see here. Now that's equals to the momentum after collision. Remember, they stick together, so it will be 4 plus 2.5 times, correct, v is in the y direction, so we just use v. So that's what you see here. 4 plus 2.5 will be 6.5v. Use a calculator and you will get 3.1976, and we're done. You can write your answer down. V equals to 3.2 meter per second.